Hi everyone, welcome back to LearnX. Today we are going to see about machine learning. The machine learning is in a branch of artificial intelligence which allow the machine or in a system to learn the patterns and relationship from the data. The model improves the performance without being explicitly programmed. Let's see what is this explicitly programmed. Before the machine learning or an AI, we usually have a problem, and for that problem we have an input, and we need the corresponding output for this input, right? To process the input, we usually write the code. These code are explicitly written by any developers, right? And machine learning will improve the performance without being explicitly programmed. Means we don't need this code anymore. What we'll do was we given a bunch of inputs and corresponding outputs to the machine learning model, and it will learn the patterns from the data. It will find some relationship between the input and output, and over a time, it will improve its performance without being explicitly programmed or explicitly coded. That's the general definitions of machine learning. When I say the learning or training, we usually use this input and output to learn the learn or train the model, right? Based on the methods of training, based on the types of inputs, we usually have in three types or four. Usually we given a there are two types of learning as in a human we usually go to the tutorials, and there will be some supervisor there, and they will teach you about some topics, and if we do some mistake, and the teacher will correct you, kind of supervising us, right? And there is another way, we simply sit at home and learn something in online or reading documentations, and there is no one around you to judge you or supervise you. So when you do mistakes, you doesn't know, right? So it's kind of unsupervised, right? So based on that, there is three types. In these are the four types of machine learning. And supervised learning, the name itself is suggests that there is a supervisor. So the input data will looks like there is an input, and there will be corresponding output for each input. So the supervised learning, we will we will give in a both inputs and outputs, and it will find the relationship between this input and output over any time, and it will improve the parameters. It's usually predict some value used within a default internal parameters, and if it's doesn't match within a corresponding output, and then it will be adjust some hidden parameters. So next time it will do some better than before. In unsupervised learning, we don't have this output, so we only have an input. So using this input only, it will learn something. It's like let's imagine like you are given some bunches of if you are given some book, and book doesn't have any subtitles, it's only having a paragraph, and all the pages are shuffled. What you can do was you simply analyze some papers and group some related paragraph together, right? Kind of grouping the data. That is an unsupervised learning. Usually in unsupervised learning, we group the similar data. That's called clustering. We usually do that in unsupervised learning. And semi-supervised learning, the name itself is suggested. It semi-supervised. It has both input and outputs, but for some some data sets, it also have only inputs only, doesn't have any corresponding output for this input. That's why it's called a semi-supervised learning. These are the tools, or the model will learn by data sets. But the fourth one is reinforcement learning. It will learn by any environment. It will it will get the sensors, or re- it will do some actions in some environments. So based on that actions, that environment will give some score to the model, reinforcement model. If the score is positive, then model will improve itself, and the score is negative, that means it's a, that's a penalty for our model for doing wrong. So it will adjust some hidden parameters likewise above. So it will also perform well over some iterations or over some trial. This is a types of machine learning. And when I say the model will be trained or learn something using data, we can't sure that the model will always do correctly, because in real world the data set has in a noises, so we cannot assure that the model will always will be correct. For that, we used to evaluate our model using precisions and accuracy. There are other methods too. Methods are there, but these two are used mainly or mostly. In real world, the machine learnings are used in spam email detections like spam or not spam, and movie recommendation systems, self-driving cars, and medical images, and voice assistants and chatbots. In upcoming videos, we will see about these types of machine learning, and we'll we will do an hands-on practice on these types, and we will do some algorithms and models. We will do lots of things in this series, and that's it. Let's see our next video.